Okay, can you hear me?
Yes.
Yes, so let's start with introduction. I will talk about hide load systems and database. Yes, let's start with introduction myself. I'm Māris Ločmelis. I'm full stack developer, so I'm not kind of the best specific guy. So maybe there will be some information that is not like actual anymore, or something like it's not the best case for the optimizations, yes, but still those options will be usable, and most of information will be viable for now, even if you compare it to the database architect level. Yes, so let's start with explanation what types of DB are there. Yes, there's SQL, NoSQL, in-memory database, single file databases.
Māris, sorry.
Yeah.
Maybe you can close that thing on top of the presentation because it's cropping up.
Okay.
Perfect. Thank you.
Okay. Yes. So I forgot that I'm sharing the screen because I couldn't match this slideshow. So yes, SQL and NoSQL in memory and single file databases. Yes, and you can ask some information and Google, or yes, find out what different databases are in and what are the difference. So I won't say it. So how high load database is related to IT? IT is information and technologies. So database is half of the information technologies stack. So it's without information technologies makes no sense, because you will have just fastly moving things that doesn't give you an impact. So in this case, it's important. Yes, so more useful information about DB I won't stay here because it's kind of not related to the team, but I will just share it. It's acid versus base. Yes, those are two types of databases. No, not types, but let's say explanations how database works and what are pros and cons for each of the database. Yes, there is my NoSQL and SQL databases. Probably acid was for SQL and base was for NoSQL databases. So let's step to the problems. Andres mentioned some, but I had others, yes, and probably hard drives he have mentioned, but I'll also have something to say, because hard drives is very huge problem for high load databases, because it's always saves, it's always reads the data, and on huge read writing there are bad sectors can happen, yes, and it will be some random error in some random query, and it will be just like signals that you need to change one of the drives on some of the machines, yes, but no, it's, let's say, the very predictable problem if we talk about SSD, because it have write reads per sectors, and you can measure it and remove the hard drive, replace it before it goes to the limit where it will become the bad sector. Also, there is problems with no write read time, yes, because database is working I think only with the memory, and even if you have SSD, it will still move the data from SSD to memory, from memory throw out and take new data from SSD, and it can be a bottleneck on high load systems, because even if it is fast, it doesn't mean that it's kind of easy thing to do if you have terabytes of memory processing in 1 second. Yes, so it's fast, but still significant. When we had HDDs, there was much more problems there. Yes. But also there is master-slave replications. Andre didn't mention it, and master-slave replications are like one database is writing and 10 database answering the correct answers. Yes, so master is up to date and slaves are maybe up to date, but maybe a bit behind. But still, for not valuable information, you can use slaves just to calculate the data. That if for example, if the data is not changing, not important to see that with second interval, for example, yes, 1 second interval, and you don't care what changed in last seconds, and probably slave is okay to send selects, and this will free up master for writing. Yes, also master will have some multiple master setups where you need to somehow adjust primary case. There are long int. You can make steps. For example, first master writes with 1, 3, 5, and second master is writing with 2, 6, 8. So they divide the number, or multiply number by position of the master. And in this case, you will have good writing and scaling, and data intersection won't have primary keys. So in this case, also for master slave, you must know that you cannot switch master in one request. No, you can, but it will be very complex to do it. So if your request started writing to first master, then probably he should use this master for everything that is coming after the write till the process ends. So it's kind of common thing to not catch magic somewhere. So also there are deadlocks on huge request amounts. Yes, so if you make very much low latency requests, then probably it could end up that they all will become high latency because of some kind of things like deadlocks from the waiting while data will be free for reading. For example, yes, waiting for data to be read from hard drive to the memory, waiting for the data to be updated by other query or something like that. And on huge request amounts, it becomes like very, very highly likely things that you will catch random time increase in some random place of your project. Okay, then there are temporary tables. They are used by engine and they are created to analyze the data, make the data output or something like that. And probably this is it's something you don't want to see on high load systems. So if you see that your query creates temporary table, probably you need to optimize it right away. This is not like a thing that will survive at least one day in huge request amount. So also there is problems with complex joins. Yes, they are fast, but it doesn't mean that always they will be fast as because when you have complex joins, then you cannot really predict the way how the table joins the records, because it can change the caching algorithm, change the cache system, and your complex join can become slow because it just changed order of keys the key processes due to some other reason where in other place it's optimized better than here. So in this case, complex joins is also things that you don't want to see in the database because it can have problems. Better to structurize it to multiple, like I don't know how to say, ORM, for example, yes, just somehow like that. But more structural syncing and requesting data by necessary, so lazy loads and something like that were possible but yes. Also, wrong field data types. It's most for the juniors. They just put the data types that they like, and the database start growing, and they start hitting the problems because they didn't expect the data will lead to problems with memory. So yes, also Andrei mentioned about indexes. Yes, he told about indexes take times to save. And he didn't tell that indexes also can flood your cache, because it's mostly like to put in warm cache where database is waiting for something to come. Yes, indexes she loves more than not indexed records. So if you will have too much indexes, then indexes will start fighting and throwing each other out of the cache, and you will come to the place where your hard drives is reading and writing cache with indexes. So don't put them too much. Okay, so also indexes could be sorted. Yes, for example, if you know that your query requires some order by or things like that, yes, then you can create sorted index for optimization place where you will have huge data set like grid or something like that to make it faster. Yes, so you can make index sorted to force it to be always from the start to the end or from the end to the start. If you have some grid where that is very often executed, to database to not mix the order of the elements. It may sometimes help, and if you made it correctly, then maybe it will solve the problem right away. Also, huge indexes, all the indexed table, all the indexed rows should be at as small as possible. Yes, so if you are making index, try to make it the lower the better. So, for example, if you are placing varchar index, then think twice how much symbols you want to in this field, because it can end up with some huge problem on index side, because index will grow and will have side effects due to that. Okay. Also, I would like to explain how database structure is working. Yes, and I will explain it to MySQL database because I have very high experience on reading this database structure type, and in others I didn't have so much experience, but when I start read, I understand that all structured databases are mostly the same. There are some optimizations behind the scenes, there are some kind of different things like functionalities that you can use or throw out if you don't need, but mostly for the structure it's kind of, I don't know, so more or less same. Yes, so first of all, yes, limit your fields. Yes, don't need to put something if you don't like to see. For example, if you don't have a name larger than 32 symbols, don't put it 128 just in case, because who cares? Yeah, database cares, because it will make a wrong structure and it will put more disk size. Maybe nowadays it has changed. I don't know how the database optimization is going, but about 8 years ago, database is storing a row in the full size. Even if you put there 2 symbols or 20 symbols, yes, so the row is full sized. There are fields, I will explain a bit more. Next slide, slide somewhere, picture. Yes. Okay, there are text fields. Yes, they are storing pointer instead of real data inside the field. So this is exception where you can put any size of data inside, and in high load systems it will be more or less okay, but they have some downsides. Yes, and I would recommend to use text fields only if you are using some comments on some large possible symbol count. Yes, for example, where you can have comment from 2 symbols or from 2000s. There's optimizations how to make it without text fields, yes, with custom varchar fields or things like that. And in this case, it could be like, but no, I won't talk about it. So yes. Also, in my instructor databases, the data is pure mathematics. So in one row, you can see the maximum size of the row, and you should understand that system is reserving the maximum size of row when she's working with cache, when she is working with hard drives. Yes, she reserves from byte 1 to byte maximum size of the row. Yes, so in this case, she reserves and she puts it from the list 1 to list 20, yes, and it tries to put the data in one sector from the hard drive or whatever it have, yes. And the reason why it is done, because easiest way to get your data is just to calculate the number. For example, you want to see 1000 row. You just say that, okay, I will multiply row size on the 1000, and I will find the pointer where to move the database forward. Yes, so in this case, it's kind of best thing to have. If it will somehow split the data, then probably it will start struggling with reading it, and it may result with slow queries where it's not expected at all. Yes, if the structure is like, if the hard drive doesn't have good structure for jumping from one row to another. Okay, so this is probably, yes. I also, index could also have deadlocks, yes. What is deadlock? It's one of the type of deadlocks is when you have index waiting for being ready. Yes, for example, you have some inserts that inserts new record, and it tries to put the index, and to update the index, it can lock all the index values inside. Yes, there are maybe modern databases will lock only new. By ID, it will generate some ID and lock the new item only. But in legacy versions, it's not working like that. It may block index levels, so it will block all indexes. Well, it won't be saved to cache. And for this, you can catch a deadlock where, for example, your database is waiting a space on hard drive to be allocated to right index, and for this time, all the database may stop working randomly in almost any direction if this index is used frequently during your project or web or whatever. Yes, so in this case, this is another reason why you should avoid unnecessary indexes, because the less you will have indexes, the faster it will save. So in this case, it will just minimize the problem. Okay, there are also useful functions for query to debug. Yes, first one is setting. I don't know how it's named in other SQL databases, but slow query log. It's like possible thing what you can enable in any production database for 5 to 10 minutes, yes, just to gather data, and then you will have tons of data to analyze and find what is wrong with your database, because it will log slow queries. There are also tools like in Azure, yes, the same. Like you can log, you can say agent to log, for example, all queries, and or log only 1% of queries and hope that you will have necessary queries in the stream. But no, anyway, it's like useful config for debugging the system at full work. Also, low resources is a problem. If you get if your resources get low, then probably you will have drop down for all the database, so it will be hard to detect where is the problem, because problem will be the resources itself. And then you probably need to add some master slave or refactor the tight spots that is using your resources without need. Okay, so there are also useful functions for queries. No, not functions, queries, yes, for console, where you can see some useful information. This is explain, and you can add analyze, and this is probably the first query you need to write before starting optimize, because explain will show why this query is running so long, and you can see there, for example, that it is creating temporary table, analyzing 1 billion sets of data, yes, and you understand that this query won't be fast at any case, so you need to optimize it right away. If explain says that this query is very optimal, and you see that this is kind of nonsense, then probably you will understand that maybe there is another query that is running behind the scene. Usually there are cases where is starting the flow, and in background it's inserting something huge and complex into the database, and you will see that there will be 20 millions of blockers, but the problem will be that there will be deadlock that is backgrounded right in this moment. So in this case, explain is thing that can point that this query should be optimized, or maybe you should look other way to find the problem. Yes, also show process lists. On high load databases, probably there are many connections, and it will be kind of very trashy. So in this case, it may not give a good overview, but for local, let's say, debugging, it's good, because you can show process lists, then kill process ID, and it will just stop the query. Yes, but keep in mind, if you are killing queries that is running more than 20 or 30 seconds, then probably killing query could lead to like more time to wait than stop it, finish, because sometimes killing query is even harder to process it. Yes, so in the case, for example, if it's running for 10 minutes and you are killing the queries, and kill query can be 20 minutes instead of 10. Yes, and probably for 10 minutes you could wait 10 seconds and it will be finished. So in this case, it's kind of a risky move, but nothing bad if you locally kill some processes. It's not like a crime. Okay, so how you could optimize something? The most common and probably best hotfix caching results, it's like you just take some place where you are returning landing page and put it in some Redis in JSON format, then you get from Redis and put it back to the client. For example, yes, you have 10,000 of landing pages, yes, and each landing page have some information that is gathering, for example, from 3 different sites where you have information about prices, about time it takes to travel from one place to another, about maybe clients that was previously flying the things, and you can just put this data into cache and read it and change it only once per 5 minutes, and in high load systems it will dramatically decrease the load from the database and even from related services that can be used in the real time. Also, there are templates. I am not common with using them, but I have seen database specialists creating template instead of tables. Yes, so they just define template where he explains the structure of template, and you can at any time just say, I want to create this template, then you fill this template, calculate the data, whatever, move it from one place to another, summarize 5 tables to one template. Then you take from this template and save to the database, and it will be much faster than you will calculate the data right into the target table. Yes, so you can create template just to create some data that is not prepared, and then just flush this template to the real database, and it will speed up your process dramatically because it won't have deadlocks on the table while you are gathering parts of the table. So it will log the template, and template doesn't have dependencies as it was created for the process. And the downside, it's just creating the tables that is probably useless, because after the process is gone, this template should be dropped. Yes, and sometimes there are crashes and templates keeps running somewhere backside. I don't know. Maybe it's not the case because as I told, it's not. But it could be a case where you have some templates that was not dropped because process is not finished. Yes, so it never told that this template should be dropped. I don't know if there is some lifetime on connection kill, but probably there could be some cron tab or scheduler that is gathering inactive templates and dropping it from the system just to free the garbage from the system. Okay, so also next is creating aggregation tables. It's it can give very good boost in cases where you see that it full table scan and creating temporary tables. In those cases, you can try to analyze if your data is more or less static. If it's yes, then you need to create aggregation table. You can create aggregation table and make grouping logic much faster than it was before. Yes, and I will show example of how it's work also in sections about batches. There are also transactions. Andrei mentioned them, but I would say that if you have multiple inserts in one place, yes, for example, you are foraging one list from the client and it have, for example, thousands of inserts, yes, then probably you can fastest way to optimize inserts is just begin transaction before you start inserting and flush the changes commit after. And it will give probably, it won't be the best approach, but it will be the fastest, and it will give about 100 times performance increase because it won't calculate on each row the things that is not related to insert. For example, check permissions, unlock tables for writing, check that record should be locked the record or even table or whatever, yes, and then unlock it again, and those operations won't be performed on each call. It will be performed only once, and probably it's about 100 times more expensive than inserting the record itself. Also for batches, I want to mention that you need to analyze how much records you want to insert in one query. Yes, it's very highly related to the database table because you can, for example, want to make one insert for 10 megabytes of data, not more. Yes, if it will be growing higher, then probably it will start waiting for cache to free up the memory, and then it will start waiting for forever while all the cache will be free because it's very huge data amount, and probably it will even drop out all the indexes from the database just to make the insertion and things like that, and it may end up by a very dramatic problem on the project. So make inserts budget, but there should be limit for one time insert. It's like most useful suggestion for anyone who is working with huge insert amount in one, let's say, request. Okay, also there is some optimization for varchar text fields. It's using CRC32 algorithm. What it is, it takes any text and it transforms to integer. Yes, the integer as outcome, it can be the same for two different strings, but for database optimization, it's like think what you want to do. If you have billions of string records, for example, emails, yes, you have 1 million clients, or maybe not 1 million, it will be okay, but for example, 100 million of clients, they have emails, and you need to search specific person with specific email. Yes, so you're writing email. If you will write the email itself, then probably it will be less optimal than if you will use CRC32 of this email and then search the email, because the CRC will decrease the records amount of its scanning by full varchar field to 10 or 20 records by integer. And for example, your email have 64 symbols, and it will, instead of reading 100 million records of 64 symbols, he will read 100 records of integer sized. So it's like, I don't remember, probably 4 bytes. I'm not sure. Yes, but you can see the amount on the optimization costs that I have found. I have found the optimization cost increase on about 5 million rows. Yes, I have quite a good PC, so it was quite hard to generate the data, but the time goes, the more cost will increase. Yes, for if I would get about 10 times more data, then probably cost would be not 10% of increase with 20, but it will be already twice faster than previous. And the more records it will come, the more optimal it will be at the end. Yes, also CRC32, you can combine table joins to CRC32, for example, sets of table joins with this indexed size, with this indexed field, yes, then you will take, instead of watching 7 tables and comparing their primary case, you will make CRC, and then the CRC will decrease the amount from, it will divide the data by integer size. So let's say like that. Yes, so in this case, it will be maybe more optimal, because seeing 7 integers is less performance than seeing only 1 integer that can divide the full data scope by integer. Next will be slow query. Yes, I will explain aggregation tables, how they work. This is kind of common problem, no, not problem, but common question for many developers, just to take some summary who gave more, for example, which person in our company earned salary, highest salary, for example, yes, and you want to find most expensive persons, yes, and you will need to make some huge data sets. Maybe for employers it's not a good case, but if we talk about clients, yes, and you have 100 million of clients, and you need to find who is of them spends more money on your business, then probably this query will be very slow. Yes, in my example, I found the query that is 1 minute and 4 seconds per execution, and usually data is static because clients, let's say, didn't disappear from history. Yes, if the client spent 100 euros, then your system should understand that he has already spent 100 euros, and you can add there 10 more, and it won't break the algorithm of search. Yes, so in this case, aggregation table will be a match, and we can create. We are first of all, thinking which fields we want to aggregate. Yes, for in this case, we want to separate by region, separate by months. Yes, separate by supply key. For example, this is something that they bought. Yes, for example, for boats and ships, we have different prices. Yes, so one guy would like to know how. Will buy only boats, other will buy only ships, yes, and you will find some optimization due to statistic data, and you will call one guy and offer some new boat, and other guy you will offer some new ship. Yes, in this case, supplementary key is just for this, and revenue is its income from this person, yes, because yes, and when you are creating aggregate table, you must also create key for last handled record to minimize the repeated data updation. Yes, you will see when we have next query why it's used. Yes, and instead of selecting, we are just updating data with new data. So we are selecting. Inserting in aggregation table data that is related from the last key order that it will be found in the aggregation rev table. It will be probably, for example, you have processed 1 million records, so ID will be 1 million, and he will start looking only from 1,000,001 record, and it will skip full table scan and jump right to the place where he doesn't know the new data, and he will sum it into the result. And this query first probably run from this query will be like same as previously, yes, 1 minute and 4 seconds. But after each repetition, it will be just 1 millisecond or less in both cases, yes. In one you are taking preparing aggregation table. In second, you are selecting data from aggregation table. Yes, and you can use here in aggregation table order by, group by, things, and everything related to not best approaches in high load systems. Yes, but in this case, it won't be so harmful because you will sort order already aggregated data, and the database will understand that you are using, and probably even the cache will be preparing the database for reading the data newly, because he will understand that there will come update and insert into with update on duplicates, and select right after. It will make the scenario, and it will optimize due to this scenario, and probably he will keep this data in the cache to read it by next query. It's high potential case, yes, for database. Okay, now let's talk about size. The databases maybe there are persons who will argue with amounts, yes, but I will just show it just to explain what you can do in some kind of database that I provided. Yes, so small database is less 1 gigabyte. Average database is between 1 gigabyte and 1 terabyte. Big database is from 1 terabyte. I didn't know, maybe 500 terabytes. Yes, big database, and after that probably comes huge database. Why I showed this information? Just to show you what you should do or expect, and how you should work in each of the database. So small database, you can work and do anything you like, and it will work fine without any problems. You will see the outputs. Yes, if you want to make something very criminal, like full database scan in one query, then probably it won't hit a load at all. In average databases, you should just evade some grouping logic where it's possible. Yes, more using like distincts, or even not grouping at all. Yes, and add some masters and slaves, and you will be fine. It will survive and work okay on almost any load. On large databases, you need to add also partitions, yes, optimizations like CRC32 aggregation tables. Yes, they will make tables less static, but more static even. Yes, but they will speed up your project dramatically. On huge databases, I don't know what to recommend, so you will need to find persons who knows database better than me, and probably they will suggest something, but I'm not sure, and I can't say for sure that it is true. Okay. What is partitioning? Partitioning is just to split database table into parts, yes, and you will just specify that this, for example, field is a part, and it will partition by a rule that you describe. For example, you can, if you have strings, yes, so you can say that, for example, partitions take from the strings first symbol. If it's A, then probably it goes to partition that belongs to A symbol. It is B, then you are moving this to partition to B, and you can separate by partitions by hard drives. Even you can separate partitions by machines. Yes, probably it's like hard way to do, and it will be overkill if you need to aggregate data from both sides. Yes, and probably it will work fine while you are in one partition, but will work not fine when you will intersect partitions. But in huge database sets, you need to partition tables, and usually it's done by the date time. So in this case, your partition will make easier to work with set of data. For example, you're partitioning table data by 1 month, and if you know that it is April, then you are just partitioning April table, and your data for other months becomes invisible for MySQL, and it works much faster. So yes, if you not sure how to partition table, you can make something like with CRC32, make some field, put it in there, and then just write that if CRC is less than, for example, 200,000, then we move to partition 1. If it's less than, more than 200,000, less than 400,000, then we move to partition 2, and so on. So in this case, it's kind of will be randomly partitioning to proper places, and you can just divide maximum integer on amount of partitions you want to have and see the, let's say, outcome will be more or less equally saved partitions for your database. Okay. Also, there is schedulers that procedures and functions. Schedulers is some background tasks. Who is familiar with cron tab, schedulers is the same for the database. Yes, if there are devs, then probably they have heard word cron. So scheduler is analog for database. Procedure is like a group of group of queries in single transaction. Yes, so procedure is for updating data. So if you have 20 tables, and you can update 15 of them, yes, and read from 5 other ones the data, then probably procedure will help you optimize the code, because procedure won't flash the change until it will done. And it won't make some kind of network traffic where you read data, put the data into some like array or whatever, yes, and then you paste this data in other procedure, and it starts to upload it to the database again. So in this case, it will evade such situations. So also functions, it's the same as procedures, but if you need something in the result, for example, set of keys that was inserted in the procedure, yes, and you will get them. And I wouldn't recommend to do them without needing, because it's make code more complex from perspective of developer, yes, because magic starts happening on the database, so it may lead to some unpredictable problems. Okay, huge databases or big databases, yes. Try to not use all drop table at all. Yes, if we talk about alter tables, then probably we need some scenarios to do it. We can't just alter existing table in production and say that, okay, it will be done. You need to do something like turn off master from the network, alter the masters, and roll up data, put the master back into the, switch with existing other master. Then you will just wait for master to finish all the queries that was took out, roll back the previous master with some algorithms that will make some duplicate checks or things like that. And in this case, start to altering other master. And it will be fully manual job from the database architect, system administrator. I don't know. Yes, probably the both persons could sit in the one chair in one moment, because it's hard to understand how to do it. But it's possible, but better not do it, because on huge tables it will take centuries to unlock the table. But alter table, it will deadlock everything, every data in this table, and you will be sitting right down and waiting while it will grow. It will unlock, and it will be disaster for you for sure. So better to not use. If you want to take out the table from the existing code, yes, I don't know, whatever, and just check that nothing is broken, just rename it. Yes, so if you change the name of table and your code is working, then probably it's okay. And even after the name, I wouldn't recommend to drop it right away. You just rename the table, wait for 1 month. If you don't have errors regarding the table not exists in so many cases, yes, then just drop it. This is the safest way to work with in huge database, because if you will drop the tables, and only place where you can find the data will be backups, and backups is very, let's say, it will take much time to read backups and insert back to the table, and data won't be full. And okay, I won't dive into it, but it will be problematic thing. Yes. So let's go. Is there any risks on renaming? As I told that there could be some cases where in procedures you was using, but you didn't notice it, for example, yes, and then from code you are removing, but in procedure it is existing, and you rename the table, and there's some procedure starts to fall because it requires tables that is not existing. Yes, there could be some other services who, for example, sysadmin was using some cron script that is reading the data from database table, and this script can fall, and scheduler can stop from this Linux system, and, for example, something is not running. Also possible solutions. This is why I told that you need to wait 1 month before dropping the table, because all those cases are magical and can come from any side you are not waiting for. Okay, so what how to optimize huge databases? It's only way of optimizing is growing the structure. So nothing else works. You can try to alter existing structures, but it will consume too much time. Yes, so only works growing the structure or working the databases, and maybe if you need to optimize huge databases, then probably recommendation is switch to microservices. In other cases, it's kind of useless thing to do. Yes, so maybe find better places for something that is hardly related to strings, yes, because if you are working with text, then structural query language is not best place where you can save those data and query them. There are no SQL. They are working with textual data much better. And also, yes, there are some commands that you can use with optimizing grouping tables. So, yes. Also, there is some distinct, which will be working much faster than group by field. Yes, if you need to find, for example, unique records, unique names or unique emails in table, if you use distinct, it will be much faster than group by this name. Also, group concat is not the best thing, because in huge data sets it may lie, because it can incorrectly group concat and even add some not existing values into this, because they was somewhere in the cache and database accidentally added it into the field. Yes, I don't know how it works, but I have problem with it, so never use group concat on large data sets. Yes. Also use always limiting, because limiting us in this picture is shown that it will grow like this. Yes, so slow, and then help, and you are done. So in this case, limiting is quite necessary always. Also, you can use paginations for limiting. Yes, it's like page 1, page 2, page 3, page 4, and it will work. Sometimes you will need even to hide maximum page from the screen, because it will be very slow to detect how many records. There are some algorithms that can say with some probability how much records it is, but anyway, you can read and use paginations even without last page. So thank you for your time. I hope I didn't extend too much my meeting. Yes, probably it's 15 minutes. I have late something, but yes, here you can see, find my training materials, and if you have questions after the Dev Club, you can always write me, email me, or yes. So thank you for listening. Now you can ask your questions if you have time.
Yeah, I have a question.
Say it loud, because the mic is somewhere.
Okay, how big should be the SQL database to start thinking about indexes? So in terms of rows, how big should be?
0 rows. You should think about indexes right away when you are creating table. It's 100%, because when you are working with structural databases, it's not like something unpredictable will happen. Yes, so if you will think on 0 and make proper indexes for joining other tables and things like that, yes, and specifying the data, you can always, let's say, for example, if your indexes will start dramatically glitching, yes, as I told, yes, you can try to drop them somehow, yes, like, but usually if you are thinking from the start, then probably they're not glitching, but you should think wisely. It's not like you just put on the all fields indexes and that's all. Yes, but you should think business case, because adding index, removing index is very complex. And when your database is growing, then when you have problem with index, for example, you can put index and the problem will be solved, and you will need to alter table. And if this table is huge, then you have huge problems, because you need already sitting down with some sysadmin to make the master slaves. And if you don't have master slaves, then probably you will need to implement the other master, and then you will need to start altering the table. So in this case, it can like show up at any time. And if you will try to think that, okay, I have 20 fields and I don't need indexes, then okay, yes. If you will think that you can skip thinking about indexes, then you will be in troubles. Yes, it's simple.
Mm-hmm. And just a follow-up question, with how many indexes should I work like simultaneously? Yes, 1, 2, or how many do you recommend?
Database is always using one index, only one. Yes, and there are additional cases where it can use multiple, like joining tables with foreign keys. Yes, foreign key is different type of index, but foreign keys usually all the databases are applying right away. Yes, it's not a question like you should do or not should do, but usually almost 100% you should do. So everyone is just applying foreign keys and it works. About simple indexes, yes, probably you should find the hardest filter fields, yes, and make filtering on those indexes like indexed, yes. And you should remember the database for where clause is using only one index. So if your index will be 5 index for 5 different fields, then it will not combine the indexes. It will pick only one of existing, so you will need to create index 1 from 5 fields. Yes, so in this case, even order in index is significant, and probably first field index should have the more collisions, the better, or in opposite way, but there are definitely collision how you place, for example, first index, second index, and third index, and you can swap the places of the indexes and see different results. So you can debug it somehow.
Last question? No?
I have a question. So about deadlocks because of indexes on older databases, what exactly do you mean by deadlocks? I mean, is it a deadlock that's never going to resolve itself and it's just dead? Or do you mean like the whole database is pretty much unusable until this gets resolved, but then it's fine?
It's like complex. If you talk about high-load systems, yes, if you catch one lock, then it can be deadlock forever. Yes, for example, you just think about grocery where you want to buy sneakers. Yes, if you have always doors open, then there will run in 200 persons per second and they won't have problem. But shut the doors for 10 minutes and then open, and then will be about 1 million clients that want to enter this door, and they will never stop because we'll start fighting. There will be some problems, and many cases performance drop down because they start to pushing each other. Yes, that can't understand who is first, who will be second. So those deadlocks are not like you are waiting for something, but it will definitely make situations that will be complex to recover. And in this case, for example, your query is deadlocking only table for 2 minutes, yes, but recovering for disaster can happen only after 2 months because it's just a problem that made 1,000 problems out of nothing. So deadlocks are very complex. It's not like you lost 1 minute and then you can recover in 1 second.
Okay, gotcha, thanks.
All right, so let's give a big round of applause for Māris.